guess we can start. What do you guys think? So happy Tuesday. I'd like to just take attendance. Signature. That would be great. I know that your supervisors in physics will greatly appreciate your attendance and record of attendance. Because I'm in frequent conversation with Maurizio Pai, who has a very high standard of excellence. He's a very good person to be friends with. Okay, so today we're going to talk about conducting a literature survey, conducting literature surveys, and some guidelines and tips on how to, basically how to get it started, and some of the challenges involved in writing literature surveys. It's a great topic. It's a really great topic. And this is not the first time I've spoken about this topic. If you can find the DataViz YouTube channel, there's a playlist called College of Science Doctoral Training Center Seminar. Say that 10 times fast. And you'll see that on there. So you see Harold's great talk from last time. Look, somebody even asked me this question, how to stay motivated during your PhDs. You'll see the last seminar before that, and some previous seminars. And there is one on the literature survey as well from last year, just for future reference. Because basically, in reality, I'm going to say a lot of things today, and you won't be able to absorb everything I say today. It's not possible, I think. It's into like learning and absorbing, it takes time. You can't just, we're not machines that can just learn and absorb all the information in an hour or something like that. So you'll take some bits away today, but you may, in 3 months or 6 months' time, look at it again, and you'll learn new things that you didn't pick up the first time. And it's the same with me, by the way. The perfect literature survey is never finished. So here's an overview of what we're going to talk about. And if there are questions or comments during this, just interrupt me. I may ask you guys some questions. Does anybody have any questions before we even start? Is everybody really excited about this? It's exciting. How many people are working on a literature survey now? You guys are not? You should be. It's part of your first year of PhD studies, right? If you're in your first year of PhD studies, at the end of your first year, you want to have a scientific literature survey finished, a draft, full draft. So if you don't know about that yet, now you know, and you need to talk to your supervisors about that. So here is an overview of what some of the topics we're going to talk about. We're going to talk about preparation, literature survey preparation, and writing. So there's a green line, and these topics are a little bit about preparation, mostly about preparation, And then there's a writing phase, and then there are lots of challenges associated with writing. This line is a little bit misleading because it applies like a binary transition from here to here, and it's very black and white, but actually it's not so black and white. It's just meant as a guideline. Look, it makes it confusing because I put there's writing, there's a writing aspect here, and there's a writing aspect here as well. So the writing does start above the green line, but the writing is really, in my opinion, part of the preparation, this writing. Whereas this writing is more focused on the literature survey itself. The main thrust or the main focus of the literature survey. So why is this such a great topic? Right? And why do we even talk about it at all? It's because, what is a PhD? Anybody know what a PhD is? Have you ever looked up the definition of a PhD on Swansea University web pages? Like what the requirements of a PhD are? Has anybody ever done that exercise? Everybody's a little nervous because nobody's done it. It's not a big deal. I just like to make everybody nervous. The idea, does anybody have an answer they want to guess? Like what they think a PhD is? Like what's the goal? And is there a way to summarize it in 1 or 2 sentences? You're all PhD students, right?
Original research.
Original research, those are two good words. But what does that mean? Why original research? What's the point? Omnia? To fill in a gap, that's a very the second half of that answer was even more interesting than the first half. That nobody else has before. What do you mean by fill in a gap?
So it should be like a new direction or a new research that no one else has done before.
That's correct. Another way of saying it is you want to make a novel contribution to knowledge. You want to make novel discoveries. You want to learn new things that nobody else has learned or contributed previously. Right? And the key phrase there is new, novel knowledge. You want to generate novel knowledge. Right? Contribute new knowledge. This is the attendance register. All right. So, in order to contribute something new, you have to know what's been done previously. And based on your study of what has been done previously, you can therefore do something new by identifying the holes in what has been done previously. That's what we're trying to do. We're trying to identify, in other words, solved and unsolved problems to look at. You want to work on unsolved problems. How do you find out what problems are unsolved? Well, partially by looking at what problems have been solved already. And that is the goal of your literature survey. Does that make sense? So the goal is to determine solved and unsolved problems. This is why we're here. Right. One of the challenges is there is a very large volume. That phrase is in italics. And those two words are in boldface. Very large volume of previously published literature. Has anybody noticed that already? It's endless, actually. So keeping up with the literature explosion is identified as one of the key challenges or one of the top challenges in any field. It doesn't really matter what field you're in. This is true everywhere. So we're going to talk a little bit about how can we navigate through this massive complexity and how can we determine unsolved problems to work on. Those are two of the central foci of literature surveys. That's why we write literature surveys, to address those two items. Is any of this sounding familiar to anybody? These phrases? Has anybody heard these topics or these phrases before anywhere? Where did you hear them?
From supervisors.
Yes, good. And at the previous seminar called How to Read a Scientific Research Paper, we talked about the same. This is really part 2 of that seminar. So the key questions we want to answer in our literature survey are: what has been published so far? How have certain studies built on previous ones? Are there any controversies, debates, or contradictions in the current literature? Have pathways of future research already been suggested? The answer to that is yes, by the way. How will your survey make a unique contribution? You can write a literature survey that nobody else has done previously. That's actually what we're going to be talking about today. Like writing a literature survey that's a good quality, it's such a high quality that you can publish it, you can do something new and publish it. That's always our goal in the database group, at least. So how will your survey make a unique contribution? This is not a requirement for everybody, by the way. That's not a requirement for every student. It's just a requirement for all the database students. But you can do this. PhD students can publish their literature surveys, and many of them do. And it makes a great thesis chapter. It makes a really outstanding thesis chapter. Which methodologies have researchers used and which appear to be best? Who are some of the key researchers and leaders in your fields? And how does your topic fit into the larger context of previous work? Is it okay if I get the attendance register back? Sound exciting, doesn't it? It's very exciting. It's very challenging, this topic. This is not an easy topic at all. So one goal, just to summarize it, make it more black and white. A survey paper is a good way to obtain an overview of the literature for finding solved and unsolved problems to work on. Has anybody here ever worked on a solved problem by accident? Not knowing that it had already been solved. It happens all the time. The sooner you sort of identify that configuration or that situation, the better. Right? If you work on a solved problem for 20 years, that's not good. If you work on a solved problem for a day, that doesn't really matter. Right? We like to publish our literature surveys in computer science. And this material is based on reading and writing a lot of previous survey papers and PhD supervision experience. And they're not easy, right? The literature surveys are difficult to write generally, and they pose a number of challenges that we're going to talk about today. What are those challenges? Number one is the vast amount of previously published literature. I don't think there'll be much debate around that challenge. There's been a lot of previously published literature, and it just keeps getting bigger. Right? That problem is getting bigger. Where to start your literature survey? That's a big challenge too, isn't it? Where do you start? That's a challenge that this seminar is supposed to help with, or is going to help with, how to start. Another challenge is deciding on a topic. That's also deciding on the scope. And we're going to talk about that in detail. How to search for literature. We're gonna talk a little bit about searching for literature, search methodology. How to deal with the previous papers. That's the topic of the previous two seminars ago. So this challenge is addressed by the seminar 2 seminars ago on how to read these papers. So you go back. Deriving a classification of literature. That means putting previously published papers into different groups that have and every paper in that group has something in common. And then determining, of course, the unsolved problems. Those two are linked. Can I just see again who has started their literature survey or a literature survey? 1, 2, only 2, 3, 4-ish. Omnia, are you doing a literature survey or something like that? Okay. Maybe today you'll get inspired. It's be like the inspiration. It will be a low energy inspiration because I'm just having some throat challenges myself. I have a cold and a cough. So about choosing a topic, this is also called scope. It determines the previous literature that falls within your literature survey, where the boundaries are between what's inside and what's outside. Right? You cannot include all previously published papers in your literature survey. You cannot do that because the volume is too big. So you have to decide on what is included and what is not included. And that's a very, very big, challenging question. So how do you choose a scope for your survey? The first step, or one of the first steps, is discuss it with your supervisor. Right? If you want to do a literature survey and you're trying to decide what it's about, you need to talk to your mentor or your supervisor, or supervisors, plural. Why is that? It's because they've been trying to keep up with the literature in their field for 20 years or more typically. Right? Maybe 30 years, maybe 40 years. So they've been trying to follow the literature for a long time. You want to exploit that knowledge and experience to find out what the good directions are, right? Another recommendation is to choose a scope that you think is too narrow. A very, very common mistake that PhD candidates make is choosing a scope that is too broad. It includes too much literature. For example, since we have a physics crowd here, you could say, oh, I'm going to write a literature survey on particle physics. It kind of sounds like sane. So that sentence almost sounds sane. But if you decide that that's your scope, then you're never going to finish, because if you try to do a literature survey on particle physics, you'll try to be including maybe 10,000 papers or something, and that's not a good idea. It means you're too wide. Your scope is too wide. This is very, very common pitfall. Very, very common. So choose one that's too narrow, and you'll find out that maybe it's not so narrow. Once you've taken a guess at the scope, do a preliminary search for papers that fall inside that topic. How many papers are you finding on your chosen topic? If you're finding too many, that means you need to narrow the scope. If you're finding like hundreds of papers that fit in the scope of what you've guessed, your first guess, it means your scope is too broad. You need to narrow it down. Now, what is the right number? There's no exact right number or correct number. I'm going to give you some numbers that I go by in the database group that I think are going to be applicable to other disciplines. However, this is only a starting point. You want to speak with your supervisor about what their opinion is and what what is typical in your field of research, right? Because it's going to differ from field to field. In our group, the rough guidelines are to aim for 20 to 25 papers that you discover in your initial search, and then look for a survey that includes roughly 50 papers total, very approximate. And that's a pretty narrow scope. Your scope has to be very narrow to get there, to fit that requirement. Another way of saying that is 50 papers per student supervisor pair. Because usually you're working with a supervisor. Sometimes, though, surveys are written by more than just a student and a supervisor. Like they could be written by 2 students and 2 supervisors, or 3, and so on. Could be big teams. But the general ratio is 50 papers per student supervisor pair. It certainly should be less than 100 in my opinion. If it's more than 100, it's gonna become something that's very, very difficult to manage. Very difficult. Don't forget to search for existing surveys on your topic. So if you've chosen a topic, look for previously existing surveys. Very, very important, right? You don't want to start a survey and then discover that it's already been done. And there's a note here. You would actually include a subsection in your introduction of how you define your survey scope. What does your survey include? And just as important is, what does your survey not include? What is left out? You have to describe those boundaries. What's in and what's out. Any questions so far about the scope? This is difficult. Deciding on the scope of a survey is difficult. And in fact, it's something that we talk about for like a year in the database group. We start a literature survey and then we discuss the scope for about 1 year, like refining it. It starts out very fuzzy, and then with time it gets more and more clear what goes in and what comes out, the boundaries. So it's really, really tricky. In some of the discussions, this is so silly, but some of my favorite discussions are this topic, and I can still remember discussions with individual PhD students exactly on this topic. Me like giving my opinion about like the scope of a survey, what should be in, what should be out. And the debate is almost always the same. It's me saying, your scope is too broad. And it's the student saying, no, I've got the scope perfect. And I say, if you choose that scope, then you're never going to finish. It's always like that. The discussions are repeating like that. And it takes me, a year to convince the student that what I'm saying is true. Anyway, some of my favorite discussions are on that topic. So searching for papers. You have to search for previously published papers on your survey topic. how do you do that, actually? It's not as trivial as you may think. It is not just using Google Scholar. Google Scholar is a good resource, but you don't want to use only Google Scholar to search for previously published literature. That would be a big mistake. So every field is going to have its own digital library, primary digital library sources. Right? Every field is going to have some special digital libraries that are going to be very important to search for previously published literature. And the only way to find those out is through your supervisor. You have to ask your supervisor, what are your favorite digital libraries to search for previously published literature? In computer science, these are two very, very big and important ones. You have to search the ACM digital library and the IEEE Explore digital library. The university subscribes to these digital libraries, right? So you can search them. They cost a lot of money, actually. But that's just computer science. Physics is going to have different ones. Bioscience is going to have different ones, and so on. Don't rely solely on Google Scholar. Another very popular one is ArchiveX, by the way, and that's for physics, computer science, bioscience. Very popular. When you do find a paper that fits in your survey scope, you look at the related work inside that paper and look at the references that it uses, it cites itself for more papers. Google Scholar is very good for if you have a paper that you know fits in your survey scope, to then find out all the papers that cite it. Has anybody tried that before? That's something that's definitely good to know if you don't know it already. So you can take an academic paper, put it into Google Scholar, and it will say the following papers have cited this paper. Very, very good to know. And again, how you search for literature is included in your literature survey. Like in the introduction. The introduction includes a description of the scope and how you did your search. How did you find the previously published papers that fit into your scope? Questions about the searching and scope? Now, if you want to publish your literature survey and you want to publish any scientific paper at all, which I hope you all want to do, you have to identify the contributions that you're making. So that is, again, very closely related to what we started this seminar with. What is a PhD? It's like expanding knowledge in some way, right? Contributing to knowledge in some way. That's what this is a statement of. Contributions. What are your contributions to knowledge? What have you done that's novel and interesting with your literature survey? Right? It would be nice that a great result is to do a literature survey that nobody else has done previously. That is really, really nice. That's what you want to do. You want to do something new. So a typical contribution would be a first literature survey on the topic T that you chose together with your supervisor. That's a really nice thing to be able to say. This is the first literature survey on this topic. Great contribution to science. Another very typical contribution is a novel classification of the literature on the topic you chose. And that's the topic we're going to be talking about in future slides. And a typical contribution is to serve as a valuable starting point on a topic, the topic that you've chosen, that can be exploited by other people that are interested in that topic. Right? So other people that are interested in that topic can use your literature survey to find solved and unsolved problems associated with that topic. And we're actually going to look at some examples, by the way, in this seminar, so it's not going to be completely abstract. By the way, many surveys are updated versions of previously published surveys. So, the most famous physics survey, do you guys know what the most famous physics survey is, by the way? It's one of the most famous surveys in all of science. Well, it's good for you guys to know this, right? It's not like, it's sort of like pub quiz knowledge, but it's still good to know if you're a PhD physicist. And we're gonna mention it in this lecture. It's a survey of particle physics. And it's the most highly cited paper in the field of physics, period. Survey of particle physics. So it has, I don't know, 1 trillion citations? No, it doesn't have a trillion, but it has a lot, right? And it's a survey that gets published like every 10 years or something, 5 or 10 years. It just gets updated and republished. So a lot of surveys are like that. That one that I mentioned is very, very special. You can do that too. You can say, I've chosen a topic where there is an existing survey already, but that survey is already 10 years old. And we now can update it with the latest 10 years of development. Okay. Another important element of your survey in the writing part, right? We're talking about writing now. That's why this word writing is here. We've gone from the preparation phase of the survey to the actual writing phase, right? Survey contributions is the writing phase. This is the preparation of writing. The field challenges. So it's very, in the introduction of your survey, it makes a lot of sense to talk about the challenges associated with research on a given topic. What are the technical challenges and the conceptual challenges and the challenges that researchers face when they're trying to understand a given topic? What does that mean? So these are just some very, very generic examples to give you some idea of what we're talking about. A generic challenge that a lot of people face, including physicists and bioscientists, is the size and complexity of data. Right? They're gathering massive time-dependent data sets, and they're trying to understand them. Dealing with the data set size and complexity is a challenge. And you would mention that in the introduction of your literature survey. And a lot of research papers will be about that specific challenge. And this is true for almost all scientific fields. Another very generic is heterogeneous data. What does that mean? Data from several different sources. Several different measuring instruments or several different devices. Right? In astronomy, you might have data from different satellites, different telescopes. In biochemistry, you have data from different microscopes and different measuring instruments, and you're trying to fuse those two modalities together. Very, very common challenge. Error and uncertainty is a very, very common challenge associated with any equipment that's taking measurements or taking photos or anything. Very, very common challenge. Another very common challenge is the cost of conducting experiments or expensive equipment. Another challenge is just the difficulty of trying to observe something directly. A lot of things cannot be observed directly, right? Because they're either too far away, or they're too small, or they're just too expensive to observe directly, or they're too far underwater, like we can't observe everything too far underwater, right? Or another classic one is if you observe something, the fact that you are observing it changes its behavior, so your observation, direct observation, ruins the experiment, so to speak. Very common challenges that you would mention. Limitations of existing hardware or software is a very, very common challenge. Right? These are very generic examples that appear over and over again. It doesn't mean they're going to be challenges for you or the focus of your literature survey, but they're just some examples of associated with challenges. Your challenges will be described in more specific terms, in more precise terms, and more specialized terms. But these are some, you'll actually find that a lot of them are related to these examples already. Okay, we mentioned the idea of classifying papers into different groups. So this is one of the big challenges in writing a literature survey, is trying to derive and classify papers. That means derive some groups and then put papers, assign each paper into a group. And there must be something in common that all the papers have in order to be in the same group. And when you succeed in doing that, you have something called literature classification. And this is a huge challenge, to come up with a novel, maybe it's not even novel, but an appropriate literature classification for your given subject. And this is something that also in the DataViz group we talk about a lot. We talk a lot about the scope. It's a long discussion. And we talk a lot about the literature classification. These two topics are discussed for a long time, several months usually. The search methodology is not a long discussion. It takes 10 minutes. And some of the other things that we talked about are very short discussions. But the scope and the classification are longer discussions. And here is a literature survey that you guys might like to have a look at. It's available online. It's called Visualization for the Physical Sciences. So it includes physics, it includes chemistry, bioscience, and so on. And it groups the papers into different categories. And it's a matrix style. So along the x-axis are your different categories or subject categories. Right? Astronomy, there are sets of papers written about astronomy, chemistry, earth science, and physics. So all these papers are visualization in the physics, in the domain of physics. Here earth science, here chemistry, and here astronomy. That's one of the dimensions of the classification. And then these are references to actual papers, actual research papers. Right? Along this, the y-axis of this classification it's called dimensionality. And that is actually, should be called data dimensionality. Right? Where is the data, what does the data represent? What spatial dimensionality does the data represent? In this case, it's two-dimensional data, and it's static. In other words, it doesn't change over time. So I know that there's exactly one paper in the literature that discusses astronomy data that's two-dimensional and static. In other words, it doesn't change over time. And then we have 3D dimensionality, so volumetric, and we have time dependent, so that's changing over time. Data is changing over time. And that brings us to 1, 2, 3, 4 different dimensionality categories along the y-axis. Does that make sense to everybody? Hopefully. That's a sample classification. Now, I'm showing this beautiful table, and it is beautiful. It's a little bit misleading, though, because it took a long time to derive this table. We talked, Dan, this is done by a very outstanding PhD candidate by the name of Dan Liebscher, who graduated a few years ago. So Dan and I talked a long time about the classification and the scope. What should be included and what should not be included. We talked a long time, and we had lots of heated debates about what should be included and what shouldn't be included in the classification. Like real fun. I still remember some of the discussions. But anyway, the end result is quite good. And it's a highly cited paper that we like to use a lot. So, a little bit more on this exciting topic of classifying the literature. That was an example of a literature classification. What are some possibilities, some guidelines about actually doing that? Is it that this is more of a little bit more of an art than a science, I would say, at this point at least. So how did we identify those categories along the X and Y axes? So the categories are often based on recurring themes. So when we have a set of papers, some themes and some topics appear over and over again. So we look for those common themes and those patterns. Sometimes for your given topic, it's not difficult to identify subtopics. So we chose, visualization for the physical sciences. If I choose that as my scope, it's not that difficult to identify the subtopics. What are the physical sciences? Like, what are the subtopics in there? Right? And that's where the earth science comes up, and the astronomy and the chemistry. Not that difficult. And then the other possibility is the data itself. You can classify papers based on what kind of data and the characteristics of the data that they're studying. And that was the y-axis in that example. What are some of the themes that occur over and over again? So look out for this. Are there any natural subject-based clusters that pop out when you're looking at these papers? And there's a tool that can help with this. It's called surveys. I'm going to mention that on a future slide. What are some of the characteristics that most of, if not all, the papers you search for have in common? Right? They all have some things in common. Look for those commonalities. The data is a very, very common way to classify the literature. Right? Any topic where there's data involved can automatically be classified by like static data or time-dependent data. That's automatically a candidate. Any questions about that so far, Amia?
How to decide about the presentation of the classification? Sometimes, In some paper they present that, for example, with one table. Some paper have multiple tables. Some paper have like design, some samples to refer to the papers.
That's a really good question. And I'm so glad you asked that this year as opposed to last year. I have an answer to that question this year that I didn't have 1 year ago. And it's called a survey of surveys. Have you heard of a survey of surveys yet? So we wrote a survey on survey papers. It's, as far as I know, it's the first survey of surveys. I've never heard of that before in any field. Anyway, we worked on that with the beautiful Leah McNabb. And in there, we look exactly at what you just asked. For every survey we look at, we identify how did they classify the literature, what style of classification did they use. And we are going to look at more examples now. But some of the styles are like, this style is the two-dimensional matrix style, but there are different styles. And let me see, this is another two-dimensional matrix style. This is not a two-dimensional matrix style. This is like just a list of categories. It's a one-dimensional categorical style. This is more like, a little bit more like a list, an organized list style, right? It's not exactly a two-dimensional matrix. This is another categorical, a group of one-dimensional categories. And another example from geography. This is categories from physics, and so on. So I would encourage you to have a look at the survey of surveys, and then you can get an overview of how people do it. Like, this is the most commonly used classification scheme. Now, what if, in my opinion, this is not everybody's opinion, a two-dimensional matrix style like this is ideal. This is actually three-dimensional because it has color. That's not really absolutely necessary. Can anybody imagine why this is the advantage of this kind of style? It's looking at you right in the face right now, if you look at it. Can anybody imagine what the advantage of this style is by looking at it?
Simple to read because you can see three of them actually at the same time.
That's correct. It's very simple to look at and read and understand. Any other answers? Any other ideas? Now, this shows unsolved problems very clearly in new research directions. So if I'm doing research, look, there's a hole. Nobody's done any research on chemistry, visualization for chemistry in 2D for 2D data. Hole, unsolved problem. Great area to work on. Right? So you easily see the holes, the unsolved problems with this style of classification. And guess what? Where don't I want to go? Look at all the people that have done lots of work in physics on 3D time-dependent data. Lots of competition in that space. It's not that many actually, but you can still identify unsolved problems in here. It's still possible, but it's more difficult. I would much rather go like here, like Earth Sciences, 3D Earth Sciences data. Big hole. There's only one person that's gone there. So that two-dimensional style, the two-dimensional matrix style, is very helpful for identifying the mature areas and the areas that are open for investigation. Now, if I compare that with another style, like this one, this is a nice categorization, right, from bioscience. They've identified the common subtopics in their survey, and then they've listed the papers that are working on those problems, which is great. But it's not as good as the 2D matrix, because I can't look at this and just say, oh, I easily see where the unsolved problems are. I don't see that here so easily. I can see, like, oh, there's more work done on this topic than this one. But I don't see the holes, like the holes where nobody's looked at yet. By the way, this is the most common style. The 2D matrix style that we just looked at is probably the least common, even though it's the most useful. Why is that? Well, one of the reasons is because it's not easy. I mean, coming up, this is another example from computer science. It's just not that easy to come up with this 2D matrix. It's easier to come up with a 1D set of categories. It's just easier. Okay, we have a bunch of papers in this category, we have a bunch of papers in this category, and so on. To come up with the second dimension or the third dimension is more challenging. Right? There is a tool you can use to help you come up with categories, and it's called surveys. Right? It lets you put all of your papers that you're including in your survey in a browser, and then you can explore some of the keywords and find out which keywords keep reappearing, how often they're reappearing. And some themes will start to become emergent and more popular than other themes. You can put the papers on a timeline to see how often those topics are being published, and so on. So it's a free tool that anybody can download and use that can help with this question of, like, okay, what are my categories going to be for my literature classification? This is an example from bioscience for the bioscientists. This is another example from bioscience. This is helpful because it does provide an overview, but it's very text-based. And it's not so easy. If it's all text like this, it's not so easy to identify the solved and the unsolved problems. This is an example from geography, right, by so-called priorities. We don't have anybody from geography here today, do we? Another example from geography. Here's a little point that's kind of sad. Not all literature surveys have a nice classification table. They don't all have that. The best ones have, but not all of them have it. It's possible to write a literature survey with no classification table. And that's too bad. But it's very common. Here's an example from physics where they've put categories of papers. They've associated each paper with one of these images, and they've classified the papers based on those categories, those visual categories. Now, one other topic is the derivation of metadata. And we don't have time to go into that very much, but I can tell you, like, I encourage you to look at the survey of surveys. You could just Google, like, a survey of surveys and information visualization. You can find it. And there's a longer discussion about deriving metadata, and that's data about the papers themselves, useful metadata. This is an example from the most famous physics paper in the world, the Survey of Particle Physics. For every subatomic particle they identify, there's a year on the x-axis, and then there's an accuracy of measurement on the y-axis. It's really, really cool. So the first experiments identifying this subatomic particle had an error range, like this error range. And look, as the time progresses, the error gets smaller and smaller and smaller until the identification of each particle becomes more and more certain. And it's done that for, I don't remember how many particles, they're like, I don't know, hundreds or thousands. Really massive, massive project. Really, really cool example of metadata. We don't have any mathematicians here. This is an example of a graph depiction of the related literature in computer science. So you can generate graphs like this that show the relationships between papers, and it gives a very nice overview of the literature, in addition to the classification. And yeah, this is just an example of the writing of a survey in the middle, right? This is a student that's working on their literature survey, and they're right in the middle. And they're writing summaries of papers based on the template we described 2 lectures ago, back in November. So every paper has that descriptive template, and we're identifying categories to put the papers in. So the papers are being placed in their respective categories, and that's me giving comments about the feedback about the writing and the language itself. Just to give you a glimpse of what that process, some intermediate stage of that process between when you start and you actually finish. And your introduction can look just like this. This is what your introduction can actually look like of your literature survey. You have your introduction and motivation that includes contributions. You summarize challenges. You summarize your scope. You summarize your search methodology. You introduce your classification of literature in the overview. You talk about metadata, and then you look at the individual papers themselves. So that's actually a skeleton-style structure for your literature survey, a very generic skeleton style that you can use to start your literature survey. Okay, that's basically it for today. That's all we can say about surveys in just 1 hour. It's a starting point. It's a huge topic. Like it takes to do a high quality literature survey takes probably a year at least. Some cases more than a year. So we tried to summarize just the beginning of that process in 1 hour, which you can imagine is not very easy. And if you're looking for sort of the survey papers that we mentioned in this lecture, here they are. And I encourage you to also look at that survey of surveys that I mentioned. I think that's a very helpful resource that is quite new as well. Any questions or comments about literature surveys? Everybody think they can go and conquer their literature survey now? You're like, oh yes, I know exactly what to do. I'm gonna conquer this. Yeah.
Is there any like specific tools that would help with the design of the classification?
That's the surveys tool. So the surveys, it's free, available online on GitHub. There's a paper about it as well. But that will help you like kind of explore the papers, extract metadata, and then find out which themes keep reoccurring over and over again. Yeah. But I'm sure if you talk to your supervisors as well, they will have ideas about literature surveys. I'm sure about that, like most supervisors would have. Some of them might even have like a list of ideas just waiting to happen, waiting for the right person to take it on and conquer the world. Any other questions about surveys? If you do have questions about surveys, you can ask me anytime. You can ask me at the next lecture, when we have one next month. And if you have questions about any other aspects of your PhD studies, you can bring them here. I'll expect everybody to give me an update on their literature study in June. Okay, if there are no other questions or concerns, we'll stop here.